Hello and welcome back to the Energy Systems and Management course. I'm excited to have you join me as we explore metering and buying within the energy management topic. Whether you're a seasoned expert or new to this subject, I promise you'll gain valuable insights from our discussion. So let's dive right in. Here are the learning outcomes of this session. Firstly, we're going to be looking at metering, which is a fairly important part of this lecture, and discussing how buying energy works and how that fits into the supply infrastructure we covered in the previous lecture, electricity systems. With this information, hopefully you'll see the importance of getting a good service from suppliers and how to ensure the key metrics of energy billing, security of supply, quality of fuel, and reliability of metering and billing are achieved. So firstly, there's the security of the supply. Is the price going to change much? Is the price dependent on how much energy you're using? Is there going to be enough supply availability? So you're not going to have issues where there are shortfalls of energy supply. So this could apply to something like delivered gas or delivered oil coming in a tanker. How often are they going to be able to make deliveries? Or it could be simply down to the wiring, where how many three-phase connectors do you need to come into your place of work or the premises to supply enough energy to power the systems? Then there's the quality of the fuel. So for electricity, this is perhaps less important. Of course, the electricity has to be of the appropriate quality, as in the appropriate phase and voltage. Or is it green electricity? But outside of that, physical fuels, oil, gas and biomass have a variety of impurities that will exist within various tolerances. These tolerances then have to be compared with the tolerances of your process, or whatever is consuming the fuel. So a relatively good example of this step is slightly out of the energy sector, but can be seen in the transport sector road fuel. So octane ratings of a vehicle's fuel, which you might have seen in the petrol stations. Finally, there is also the reliability of metering and billing. This is a wider point about how smooth the interactions and transactions with the energy companies are. The billing needs to be accurately metered, of course, but it also needs to be accurately priced. All this ties into that final bullet point on bill validation and payment. You have to have a way to validate how much energy you're using, and, thus, how much it costs. So a bit of background thinking to consider. Energy is one of the biggest costs for commercial, residential and business sectors. And depending on your business or home usage, it can be 40% to 50% of the process costs, and even higher if you have a high-energy process being used, like maybe some kind of arc welding company. If you think about your energy bills at home, you may notice it's one of the largest bills you pay across the year, probably more significant than any of your other bills, aside from your rental mortgage payment. So energy costing is very important. It takes up a lot of the time and money involved in running a business or a home. But another thing to think about when talking about or thinking about your home bills is how much the energy bill varies between different quarters or monthly, depending on how you have yours paid, and how much it can be varied to reduce costs. Your energy bill depends on your behavior as a consumer. Thus it is one of the easiest bills to reduce, and one of the ones that you can reduce by the largest amount in terms of the amount of money saved. And this applies to business as well as home life. And this is where energy management comes in, as we discussed during the Introduction to Energy Management lecture. So because it's relatively easy to change behaviors to reduce energy usage, we can use that effect to save a lot of money very quickly. So remember that energy management is defined as the process of controlling, monitoring and conserving energy. If we accurately monitor our energy usage, and in this case by accurate metering, we can control and conserve that energy, thus reducing costs both at home and in business. Simply, metering is the measurement of energy consumed by a site, building or individual process. Within the subject of energy management, metering is part of the monitoring topic, and in particular, we're looking at the measurement of energy consumed. And as part of the energy manager's role, it is important to know how energy is being consumed, where energy is being used, and how is being purchased. Effective energy-saving measures naturally follow robust energy metering techniques. So the primary objective of energy metering is to help you control the use of energy effectively. So if you think about the monitoring aspects, we can use the metering to monitor how much energy is being used. But if we meet them more effectively, we can also measure how the energy is being used, and from that monitoring, build up this pattern, and see how the energy is being used by the business or the premises over a particular period. And then we can set targets for how that energy usage can be reduced. And we can measure our progress towards those targets by metering as well. So metering is sort of the beginning and end of this process. We need to start off by metering to work out how much energy we're using. And then we need to monitor the energy usage, hopefully decreasing as we approach our targets for energy reduction. There are two main families of meters. There are primary meters and secondary meters. So primary meters are also known as fiscal, revenue, or billing meters. These are the meters that stand on the frontier, stand on the border between the supply side, the grid where the energy is generated, transmitted and distributed, and the demand side where it is being used by you, the consumer, or the business that you're working with. So that is the line between the supply side where the energy is being produced and the demand side where the energy is being used. These meters measure how that energy moves from the supply side to the demand side. If we consider water to be like electricity, the main water pipeline comes off, goes through your meter to measure the water usage in your building. That water meter is the primary meter. It is the point at which the water main in this context, with the electricity, the grid enters your property, or the property that you're working on. The secondary meters then are additional meters after the point of the first primary meters. And these are used to subdivide the energy usage downstream. So this meter may be in one wing of the building, or another wing of the building, or there may be several meters, or they may be on different floors. These meters can be installed to measure typically at lower voltages, and they can localize where the demand for electricity is being met. So you can see whether one part of a building, or one building as a separate part of the sort of complex, is using more energy than another one. So the data from the meter can tell us how energy is being used. For example, a secondary meter can provide electricity data and can be used to get a good picture of what processes are happening within a particular business over the course of the period of time. Here, this graph shows half-hourly electricity use at given times a day, across the period of a week. Now it can take a second to adjust how you look at this graph, but what we are seeing is the cumulative energy usage over the course of the entire week. So this graph is not showing that the most energy usage was on a Sunday. It is actually that the Sunday was the last day of the week. So all the previous energy usage for the week is below it. So if you were to graph this starting from the bottom left, with the dark blue line for Monday, that would run across as time passed on to the end of the day, and then Tuesday would start. And if we reset the counter of the energy usage to 0 at this point, all these lines would overlap, and it might be quite hard to see cumulative effects. So what we've then done is that the Tuesday line, the orange line is showing the combined energy usage for Monday and Tuesday. So Wednesday is showing Tuesday, Mondays and Wednesdays, and so on and so forth. So the Sunday line is essentially showing the entire week's accumulation. But by splitting it into days, we can see different behaviors. As you can see, we have these three main periods. The base load where the lowest amount of energy is being used, which is relatively even each day. And then we have the shoulder hours, where we have a step up or step down in energy. The shoulder hours for this business are at 6 in the morning, and then 6 in the evening, 18 on the 24 hours clock. And then you've got the flat higher usage level in the center of the graph, which contains some spikes, peaks and troughs. You can also see some peaks and troughs in the baseload on the latter days of the week, which we'll come onto in a moment. So what we can see is this business is using about 750 units. The units on the left side are not shown. So could be kilowatt hours, could be megawatt hours if it was a massive business, or could be watt hours if it's a very small business or building. Whatever the units are, 750 of them are being used during the baseload period. And then that energy usage jumps to 1,000 units during the day, between sort of 6:30 and about 5:30 when it starts to tail off as the business closes down. So the shoulder hours at the start could easily be workers arriving, or they could be the cleaning staff arriving, or people arriving to start up machinery. And then at the latter part of the day, these are the last workers leaving. And you can see that the latter part of the day has a much gentler slope for the shoulder period on the right. And this could be shown by people leaving early, or finishing their jobs early, or a process winding down over time. By comparing the energy demand profile of what is known about the energy consumption, we can work out how much energy should be used where. So for example, we could see that the business is working on a Saturday. There is a certain degree of Saturday activities. We could look at whether that's a cost-effective use of energy, whether the energy cost is worth the limited production on Saturdays. And even if it is, maybe the workers could work slightly in different patterns on Saturdays to avoid heating the entire building. Maybe we'd only have to heat part of the building, or only have to power part of the process on Saturdays. In the bottom line, the data provided via meters provide us information about how these processes work and also how the energy is being used. By factoring that in, we can get a good understanding of the overall processes that are happening and where the energy can be best saved. Lastly, we're going to look at the energy industry supply chain. So this is for both electricity and gas, but it's probably clearer just to look at electricity for a moment. So as we saw in previous lectures, you split the energy supply chain into generation, transmission and distribution steps, where the energy is made in the power plant, and it's transmitted at high voltage over long-distance power lines. And then the voltage is slowly stepped down to the local distribution until it reaches your house or your business. But how it is then charged, and how it is then paid for, is where the energy suppliers come in. The energy suppliers are potentially a separate entity or organization from the energy producers. You have the companies running the big power plants, then we have the companies running the distribution networks. So for electricity, these are the transmission lines. They're maintaining the big pylons and maintaining the substations. And then the suppliers are kind of the customer-facing side of the work. They are the ones who set up your connection, work out your tariff, do the meter readings and so on and so forth. And as you can see, most of the cost of making the energy comes from the producers. It comes from actually making the energy. It comes from the cost of the fuel, or the cost of the infrastructure that was used to make the energy. Then the distributor's cost, obviously for transmitting the energy to you. So in the case of gas, these might be tanker deliveries, or they could be pipeline installations. And finally, a relatively small slice of the pie is the suppliers who deal with the customer service side of the supply chain. You need to remember that a large proportion of gas and electricity is supplied under contract, and therefore, there is an opportunity to negotiate terms or switch your supplier to a better deal. But in addition to the negotiations, you have to be aware of extra charges that might appear that might not be mentioned in the negotiation, or might only be briefly mentioned in the hope that you don't explore them more fully. For example, these can include standing charges or contract renewal change charges. Thank you for joining me in this short lecture video. I hope you found the content both informative and engaging. For a more in-depth understanding of the topics covered, please refer to your course handout, which accompanies this lecture video. The handout, prepared by Professor Zandi, contains valuable supplementary materials that will enrich your learning experience. Your commitment to education is greatly appreciated. If you have any questions or need further clarification, don't hesitate to reach out. We're here to support your academic journey. Once again, thank you for watching, and I look forward to our next learning opportunity together.